अस्सलाम वालेकुम डियर स्टूडेंट्स। तो जो हमारी नेक्स्ट प्रॉब्लम है दैट इज ऑन Poisson इक्वेशन. So if I take one example on one problem on this Poisson equation, and similarly we can also do some problems on this Laplace equation also. तो पहले हम एक देंगे, if we have some potential that's given V is given to us, so V will be equal to and this epsilon is 2.25 and we need to find rho at तो हमारी जो प्रॉब्लम है तो हमें कैलकुलेट करना है कि चार्ज डेंसिटी with given potential V equal to this 5x cube y square z and this epsilon, so it is not free space, we have that epsilon, that is 2.25 epsilon naught, right? So we know from that हमें पता है कि that Poisson equation we write that we know that so it was so it's not no free space, ये free space नहीं है, तो it is that epsilon है, so इसीलिए मैंने यहाँ पे epsilon लिखा है. But in many other lectures हमने वहाँ पे लिखा था minus rho by epsilon naught, so that was for free space, but our space is not free, so it has some value, so that's why इसलिए मैंने Laplace equation लिखी minus rho by epsilon, right? Now अगर आपको पता होगा this equation, this Poisson equation, ये किस coordinate system में हम ले रहे हैं, so this is very important. So this is simple in that rectangular coordinates, right? Because if you write this, अगर हम Laplace equation लिखेंगे in cylindrical coordinates or spherical polar coordinates, so this equation will be a bit difficult to remember, right? So usually हम जो ये Laplace this Poisson equation लिख रहे हैं, it is in this rectangular coordinate system, right? So this is very much clear that we can write that this nebula square V as partial to x. Okay, so let's calculate. If I calculate now, what will be the partial 2x by partial x2 from there? तो यहाँ पे क्या आएगा? Because we need to differentiate it partially. तो हमें partial differentiation यहाँ पे करनी है. तो first is it is with respect to x. तो जब हम with respect to x यहाँ पे निकालेंगे, so this will be 5 into this will be 3x square, right? And again, if I differentiate it, so this will be 6 of x. 6x into 5 y square z, because y square and z remains constant, right? तो हम लिखेंगे, so first term will be, it will be 30, that because x cube की होगी 3x square, and then again because it is partial to, so again that 3x square will be 6x. 6x into that 5, that will be 30x y cube y square z, right? And similarly, जब हम इसकी differentiation करेंगे, so partial to y by partial by 2, so this term will be equal to plus when I differentiate it with respect to y, so this will be 2y, then 2, so this will be 10 x cube into z. Because it is 2y, then again when we differentiate it, so that will be 2. So 2 into 5, so 10 x cube z. And similarly, जब हम इसकी differentiation करेंगे partially with respect to z, right? So with respect to z, so first it comes out to be 5x cube y square, but again when we differentiate it, so this will be 0, right? So it will be 0. So that will be equal to minus rho upon epsilon. Okay? Because we have this epsilon equal to this, right? Because our space is not free, so it has some permittivity here. Okay, so let us write now. So this will be equal to, or you can write that rho will be equal to, that will be minus epsilon into 30 x y square z, ओके। तो यहाँ पे हम क्या करेंगे, वी विल कैलकुलेट नाउ। सो रो हम लिख सकते हैं, सो दैट विल बी इक्वल टू, एप्सिलॉन को अपना वैल्यू लेंगे बिकॉज एप्सिलॉन इक्वल टू 2.25 एप्सिलॉन नॉट, राइट। सो एप्सिलॉन नॉट इज दैट 8.85 to 10 power minus 12 coulomb per kg, right? Or you can write this as so it will be 2.25 minus 2.25 into 8.85 into 10 power minus, right? Because epsilon naught is this one, and inside will be, so within the brackets will be, that will be 30 x y square z, okay. Now because हमें calculate करना है कि what will be the charge density at these points, -3, right? -3, so that means that x equal to -3, y equal to 1 and और z will be equal to 2. तो वहाँ पे हमें देंगे कि कितनी charge density हो, right? So we can write that what will be the charge density at 3, that's -3, 1 and 2. So that will be equal to, so if I calculate this, so it will be some minus 2.25. Suppose this is some approximately 8.85 into 10 power minus 12, right? And inside will be, when I substitute here -3 here, so it will be minus 90. Huh? So that will be minus 90, and this is here z, so z is 2, so it will be minus 180. So this will be minus 180 and minus 540, because यहाँ पे मुझे substitute करना है कि x equal to that -3, so -3, this will be minus 90, y is 1, so 1 square, and 2, minus 90 to 2, that's minus 180. And similarly, second term is that is 10x cube into z. X is that's -3 cube, that's 27 into 10 into that 2. So this will be minus 540, right? Or you can write that. So let me write its value. So the rho comes out to be, so it comes out to be 14.3, because minus minus will be plus, it will be 14. That is a 1434 nanocoulomb per cubic meter, right? So you can calculate what will the charge density at these points with given potential minus, that is 5x cube y square is that, right? And similarly, if you want to calculate now, if I have the some value of this v, and you want to calculate that whether that potential should satisfy our Laplace equation or not, right? So that means, suppose our z is given us, z is given to know, so this, suppose v is equal to, right? तो हमें potential यहाँ पे दिया है, so potential is known to us, so we need to check whether it satisfies तो हमें देखना है कि whether it satisfies our Laplace equation or not. तो हमें पहले फर्स्ट ऑफ ऑल हमें देखना है कि what we have to calculate. We need to calculate that Laplace square v should be equal to 0, right? तो उसके लिए हमें जो Laplace square है, so we can write it. So in which coordinate system we have to write? So we need to write it in terms of that cylindrical coordinate, because we have that rho finds that. So पहले आपको चेक करना है कि जो हमारा potential किस coordinate system में दिया है, right? So first guess that when you guess that which coordinates, in which coordinate system our potential is given, तो उसके बाद you need to write that Laplace square that in terms of those coordinate systems. So that means we need to write that Laplace square in cylindrical coordinates. And one more thing, that you cannot directly calculate that Laplace square v, because v is our scalar potential, right? So you can calculate. So instead of that, you need to calculate that nebula into nebula of phi. Nebula. Because you can take the gradient of a scalar, you cannot take the gradient of vector. And similarly, you can take the divergence of a vector quantity, right? So first to calculate this term, then you take the gradient of that, and we will see that if it will be equal to 0, so it should satisfy our Laplace equation. So there are one more example. Suppose I will take that if our V0 is so there is one more example that if V0 equal to 30 cos theta divided by r square. तो यहाँ पे आपको पता होना चाहिए कि potential किस में दिया है. So potential it will be given in spherical polar coordinates, right? Because it is theta and r, so phi is not there, but at least these two are right. So this is in cylindrical coordinate. Maybe we will do it in next time because so I should stop now. Thank you.